Hello, I'm Carlos Rosa Suarez, and this is the CRS channel. We are going to continue with our word problems, and here we are going to follow with, we're going to continue here with a exercise 4B, which says that at what time between 4 o'clock and 5 o'clock do the hour and minute hands of the clock coincide? So remember here we have the same thing as the exercise 4a. The angle swept by the minute hand should be equal to the angle swept by the hour hand plus the initial angle of separation between both hands plus the final angle of separation between both hands as specified in the exercise. Now, here for B it says that the minute hands of the clock should coincide. That means they should meet. That means that the final difference angle is 0. So here we only have the angles swept, and here we have the difference angle between the two, the initial difference angle between the two. So pi over 30 times t equals pi over 360 times t plus 2 pi thirds, and multiplying by 360 we have crossing out the pi's, I have 1 over 30 times t equals 1 over 360 times t plus 2 thirds. So multiplying by 360, I have 12t equals t plus 360 over 3, which is 120 times 2 is 240. So I have 12t equals t plus 240. 12t minus t equals 11t, and 11t equals 240. That means that t equals 240 over 11, which is 21.8181 minutes. So at t equals 1, it's 4 o'clock, between 4 o'clock and 5 o'clock. That means that t equals 4 o'clock, 21 minutes, 49 seconds, 90.9 milliseconds. The hour hand and the minute hand meet or coincide. Now we go on to exercise 4c. Which is at what time between 6 o'clock and 7 o'clock. So the initial difference angle between the hour hand and the minute hand is pi, which is 180 degrees. So that the angle swept by the minute hand equals the angle swept by the hour hand plus the initial difference angle plus the final difference angle between the two. Now here, since it is specified that the hour and minute hands should be at a right angle, that means that we have two possibilities. If I'm considering the time between 6 and 7 o'clock, the hour hand should be between 6 and 7, and the minute hand should be between either 3 and 4 or between 9 and 10. Remember that if I start from 6, the 90-degree angle would indicate position at 3 or at 9. So as it moves, as the hour hand moves from the 6 mark to the 7 mark, it means that I am considering the minute hand being between the 3 mark and the 4 mark, or between the 9 mark and the 10 mark. Okay, that means that in one case the minute hand should be behind with respect to the hour hand. That is the case when it is between the 3 mark and the 4 mark, which means that when I consider the angles swept here, that would mean that, for example, the angle swept by the minute hand should be equal to the angle swept by the hour hand plus the initial difference angle, which should be pi. And here we have to have that if the initial angle, the final angle, sorry, if the final angle is such that the minute hand is behind with respect to the hour hand, then here it means that we have to subtract subtract pi halves radians. So we have that pi over 30 times t equals pi over 360 times t plus pi minus pi halves. That means that canceling out the pi's, 1 over 30t equals 1 over 360t plus, here would be 1 minus 1 half, which would be 1 half. So multiplying by 360, I would have 12t equals t plus 360 divided by 2, which is 180. 12t minus t equals 11t, and 11t equals 180. And t, that means that t equals 180 divided by 11, which is 16.3636 minutes. Now, if you look at the clock, I was considering that the minute hand should be between the 3 mark and the 4 mark. For the minute hand, that would mean that the time would be between 6:15 and 6:20. And that means that the result of our exercise means that the time is 16 minutes 21 seconds 818 milliseconds. So we can assume that our solution should be the correct one. Now, in the case in which we are considering that the minute hand has passed the hour hand and is ahead of the hour hand, which means that the minute hand is between the 9 mark and the 10 mark, and means that it is between 6:45 and 6:50, time between 6 o'clock and 7 o'clock. Then instead of subtracting the pi halves, we have to add pi halves. So we have almost the same equation, only that the pi halves radians considered is added and not subtracted. So we have the pi over 30 times t equals pi over 360 times t plus pi halves. So we have 1 over 30 times t equals 1 over 360 times t plus 1 half, which is 3 halves. Multiplying by 360, we have 12t equals t plus 360 divided by 2, which is 180, times 3 is 540. 12t minus t equals 11t, so 11t equals 540, which means that t equals 540 over 11 minutes. Remember, we're considering that our time is between 6:45 and 6:50, and we have that our time is 6:49 minutes, 5 seconds, and 455 milliseconds. Sorry, which is between 6:45 and 6:50. So we can consider our result correct. Okay, so we are gonna continue our next video with problems pertaining solutions to sets of equations. We're gonna have a series on solving sets of equations, and we're gonna start that in the next video.